Today's video is a brief video on finding the scale factor in similar figures. So don't forget to fill in your note sheet as you watch the video, and we'll be doing a little bit of this in class tomorrow. Only similar figures will have a scale factor. So if you are not similar, there will be no scale factor to be found. Oops, figures, sorry about that. Similar figures. Let me erase this so you can see what it actually was supposed to say. Similar figures will have a scale factor. In everyday terms, what do I multiply the lengths of the sides of one figure by to get the lengths of the corresponding sides on the similar figure? In mathematical terms, you're looking for the ratio of two corresponding lengths in similar figures. So how do you find it? Simply make a ratio of the corresponding sides and simplify. So if you were determining if two figures were similar already, you've already actually made those ratios. So if you simplify the ratios, you have found the scale factor. So I will do a few examples here with you. I'm actually going to do each of these examples in two ways. So I'm going to go ahead and split the excuse me, the screen down the middle for the two different ways. So you're going to remember that to determine if figures are similar, we identify corresponding sides and we make ratios of corresponding sides. So whenever you're finding a scale factor, you already know that the figures are similar. So in this case, these figures are already similar. So how do you find the scale factor? Well, you just simply take a set of corresponding sides and you simplify them. So I'm going to take the side AB and the corresponding side DE, and I'm going to make a ratio 3/1. And it already is simplified. It's 3/1. I could have done any of the sides though. I could have done AC to DF, which was 9/3. When I simplify that, you could see that that's 3/1. Or I could have done BC over EF, which is 6/2. And again, when I simplify that, I get 3/1. So as you can see, it wouldn't have mattered which set of corresponding sides you got. You would get 3/1, which is really just a scale factor of 3. So what does that mean? Well, in this case, what I found was the scale factor of the smaller figure to the larger figure. If I look at the smaller figure and I multiply each of the sides by 3, I get the length of the corresponding side. So 1 times 3 is 3, 3 times 3 is 9, 2 times 3 is 6. So simply I found the scale factor, or like I said, in everyday terms, what do I do to the lengths of the sides on one figure to get the corresponding length on the other figure? Like I said, I'm going to do each one two ways because, as you know, you could do your ratios in the other direction. You could have done, instead of triangle ABC over DEF, you could actually do it the other way, triangle DEF over ABC. So instead of doing 3/1, I could have done DE over AB 1/3. Or instead of doing 9/3, I could have done 3/9, and I could have done 2/6. So had I done my ratios in the other direction, all of these ratios simplified to 1/3. So this is the scale factor is a third. So why are they different? Well, this is just the scale factor if I was looking from the larger triangle to the smaller triangle. So in that direction, it's times a third. So if I take 3 times a third, I get 1. 6 times a third, I get 2. 9 times a third, I get 3. So which one do you use? Well, actually, it doesn't matter unless the question specifically says find the scale factor from the larger triangle to the smaller. Then you must use a third, because to get from the larger to the smaller, you multiply by a third. Or if the question specifically asks what's the scale factor to get from the smaller triangle DEF to the larger triangle ABC, then you must answer with 3, because scale factor to get from the smaller to the larger is 3. Otherwise, it doesn't matter. Okay, let's do one more. So here's one with a quadrilateral or rectangle. And again, when you're finding scale factor, the figures are already known to be similar. So again, I'll do it both ways. I'll find from the smaller to the larger and the larger to the smaller, or vice versa. So I'm going to start with triangle A or rectangle ABCD over rectangle, let's see, I can't really see there, EFGH. And it would be 3 over 12, or I could do 2 over 8. Either way, when I simplify these, I get 1 over 4. So the scale factor is 1/4. Now that would be, what do I multiply EFGH by to get to the smaller triangle ABCD, and it's times 1/4. If I were going to look in the other direction, I would do the larger over the smaller. 12 over 3 is going to give me the whole number 4, and 8 over 2 is going to give me the whole number 4. Either one works. Again, you don't have to do them both. And that's what do I multiply the smaller lengths by to get the corresponding length in the larger triangle, times 4. So in this case, the scale factor is 4. So again, it doesn't matter which one you give unless the question specifically asks what is the scale factor from the smaller rectangle to the larger rectangle. Then you need the whole number times 4, because to get from the smaller to the larger, you're multiplying by 4. Okay, so hopefully this is a little background on what scale factor means, and I'm going to do a little review of everything we've done so far in similar figures on the next page. Okay, so this is everything we've done so far, and you'll get this note sheet to keep in your notebook. So how do we tell if figures are similar? That's the first thing you learned how to do. So we make ratios of corresponding sides. We simplify those ratios, and if the ratios are in proportion, then they're similar. The figures are similar, and if the ratios are not in proportion, they're not similar. The next thing you learned how to do was find missing measures on similar figures. So we make a proportion using ratios of corresponding sides, making sure that one of the ratios in the proportion involves the missing side, and then we solve the proportion using cross products. And then anytime we have similar figures, we can find the scale factor, which is what you just learned in this video. So once you know the figures are similar, simplify one of the ratios of the corresponding sides, and you found your scale factor. So just let me back up here to how do we see if ratios are in proportion. There were a couple ways we did that. We said you can find the cross products, or we can simplify the ratios, or even turn them into decimals. I forgot to review that with you. So hopefully this video has helped you, and this is a nice review of everything we've done so far with similar figures. And I'll see you in class tomorrow for more practice of all of this. So have a great night. Adios. Ta-ta. Until tomorrow. See you soon. Have a great night. Bye-bye, guys.
Made with Doodlecast Pro.